Okay, welcome to everybody for this fourth edition of our sessions of webinars from Emconsoil. And I see that still people are coming in, but I think it's time to start. To be honest, I'm really honored that Hans Lenders from Arcadis Nederland accepted to give here a presentation on PFAS. Hans Lenders is a senior consultant at Arcadis Netherlands. He has been working on soil and groundwater remediation for over 30 years, and he has been working on consultancies and research institutes, and of which already 10 years on PFAS. He's co-founder of the Dutch Expertise Center on PFAS, author of technical documents and guidelines on PFAS. He's member of Nicole Working Group PFAS, and there is so much and many more that Hans Lenders has been doing in the recent years. So it's really an honor to introduce you, Hans. Can you share your presentation, and I'll give you immediately the floor.
Mute,
Hans,
yes.
Yeah. Okay,
there
that's fine now. Yeah.
Thank you for your kind words, Johan. I will do my best to give an interesting talk. I will be talking to my screen, so there's limited room for questions at the end. Let me start my screen. Just give me a second. There it is. I hope you can all see it.
That's fine.
That's fine. So, and I'll kick it off. Thank you a lot for your introduction, Johan. I think that's enough about me. We're going to talk about PFAS and how we have to deal with it. When you look at this picture, this is the Holmenkollen ski ramp in Oslo, where I did this talk, in fact, in September last year. And since then, a lot has already been changed. I think it was a nice picture because also in ski wax, you know, there may be some PFASs, and this is a short disclaimer from my side that the PFAS world is traveling very fast. So some of the elements in this presentation, I tried to update as much as I could, but some of them may be already a little bit older. So if there's any remarks or questions, please do so at the end. I'll do my best to keep it interesting. And I think I've updated it to the most parts of it. So we'll see. So here it goes. Oh, beyond the planetary boundary. Last summer, an article came out from Ian Cousins. You can see the first citation there, that PFAS is beyond the planetary boundary of our planet. And you can see that last year there was a health advisory level in drinking water from US EPA of 4 picograms per liter. Our Dutch RIVM has put forward a level for surface water of 7 picograms per liter. I'm not talking about nanograms, but picogram. And therefore, it's no wonder that we can find those contaminants nearly everywhere. And Ian Cousins concludes, well, it's outside the safe operating space of a new planetary boundary. I must admit that in his article, I believe he talked about the drinking of the level in Denmark, 2 nanograms per liter. And that's still valid. And the picograms per liter values are advisory levels, I must say. But still, you can see it's very, very low. And last year, I also came across another article which I think is very interesting, because we're talking about climate change, etc. And Professor Ravi Naidu said, well, climate change is our second largest environmental problem. We need to get serious about the largest, which of course is contamination. And I think that's important because climate change attracts a lot of attention. But if you look at the amount of deaths per year around the globe, contamination is the cause of many more casualties. There's no escaping the toxic chemical avalanche. I will get back to this. But keep this in mind. In every citizen's mind, they realize that climate change is important, but do we realize that contamination is important? This is not only about PFAS, by the way. but this is about contamination everywhere. Okay, keep that in mind. Now, looking at that picogram per liter level, I always like a quiz and something just to keep people involved. And I'm going to talk about regulation, which is a bit dull, so just a short quiz. 4 picograms per quadrillion, 4 parts per quadrillion, or picograms per liter for P4 in drinking water. Do you know what 1 part per quadrillion is? So just keep it in mind. Just think, is it 1 human hair out of all the human hairs in the world? Surely a lot of human hair. Is it 1 second in 320 centuries? Or 1 grain of sand in the Olympic-sized swimming pool? Or 1 centimeter of 600 times around the Earth? What do you think it is? Keep it in mind. I'll give the answer immediately. What do you think? Just to get you involved. This is all parts per trillion, or nanograms per liter. So you already know that a nanogram per liter is really a very tiny amount. It's 1 second in 320 centuries. But indeed, a picogram is 1 human hair out of all the human hair in the world. And I got this one from Cefic. And Cefic already says this: there are no analytical techniques that can measure with this degree of accuracy. So 1 picogram, that's where we're going at. Another question. Perhaps you might know this because it was in the news very often, but still, we just talk about picograms, which is health advisory rates. Now look at the PFAS in your blood. And I express it in nanograms per liter, I must admit. What do you think is the level of sum of PFAS in your blood? 3.5, 89, 960, 19,800? What do you think? And again, I'll give the answer immediately, and keep this in mind when I go through all the data and regulatory values. On average, a European citizen has around 20 micrograms per liter in his blood. So that's really a lot when you think about the health advisory level for drinking water in the US. People often say, I can drink your blood. Well, I wouldn't do so. I wouldn't do so, really, I wouldn't. Now, continue with the real thing of my presentation. Setting the scene. What am I going to talk about? First, the reference, the guidance values and the relative toxicity of PFAS. Then I'm going to show you all the environmental data. In fact, that's where my presentation is about. What do we find? Which levels, concentrations do we find around us? In soil, water, blood, vegetables, consumer products, waste, dust, and then a reflection. What does this all mean? What do you think? I'll try to give an objective view. So it's not an opinion. I just present things as I think they are. And it's all based about data. As I said, I try to update all these, but things are changing and it's nearly impossible to keep up with everything. Now, going to guidance values and relative toxicity. Talking about the tolerable daily intake. So what is a sensible level that we can intake before there's an effect? As you can see in the graph, since 2008, which is not really a very long time, it has decreased dramatically. And in the table on the right-hand side, you can see that, for instance, for PFOA, the tolerable daily intake in nanograms per kilogram body weight per day decreased from 1,500 to 0.63 for the sum of 4 PFASs. And for PFOS, which was in 2008 10 times lower, from 150 to 0.63 sum of 4 PFASs. And what's one of the main reasons is that this endpoint was first determined by animal studies, and in the end, as some of you may know, EFSA based its opinion on epidemiological studies, which means studies on humans, on human populations. Okay, so that's the big decrease, and that's the reason that PFAS receive a lot of attention, because they are everywhere. Now, moving on. As Johan said, I'm in the Netherlands, so I know a lot about the Netherlands, and I think that in the Netherlands we did a lot of research lately on PFAS. And especially Dutch RVM has done really a lot. And most of us work, I think, in the soil and groundwater arena. So this is where we are looking at. So our intervention levels for PFAS and PFOA or GenX, they're reasonable. Let's say about around 60 micrograms per kilo. But look at groundwater. When you look outside of groundwater protection areas, also they're reasonable. But groundwater protection areas are based upon drinking water levels and intake. So, for instance, for PFAS, I will say this 10 nanograms per liter, and PFOA 20 nanograms per liter. And our advisory level for drinking water is 4.4 nanograms per liter in PFOA equivalents. I will get back to the PFOA equivalents in the next slide. And just recently, or relatively recently, there was the drinking water guidance from the European Union. That's only a couple of years old. It's still 100 nanograms per liter for, I think, the sum of 20 and 500 for all the PFASs. I'm not sure, but 100, which is much higher, much higher. And for the first time in the Netherlands, we make a distinction between groundwater inside and outside of groundwater protection area. So there you can see the difference between those two. Now getting back to those PFOA equivalents. This is a slide where I try to explain the PFOA equivalents. You see a lot of PFAS congeners or PFAS compounds, and you see a lot of numbers. When you look in the middle, I'm not sure if I can, perhaps I can make, yeah, let me check. When you look over here, there's PFOA and PFNA and PFDA. You can see that PFOA has a PFOA equivalent, of course, of 1. And this expresses the toxicity, the relative toxicity compared with PFOA. For instance, PFAS is, that's over here, has an RPF factor of 2. These RPFs are based upon animal studies, so not about human endpoints, animal studies. So that's different than the EFSA-4. But this gives the opportunity to calculate a combination toxicity of PFAS, which we see already in European proposals for guidances. And I made a resume of the 4 most important PFAS that you will find in the EFSA-4. For instance, if you have 1 nanogram of all these 4 PFASs, you will calculate 13.6 nanograms PFOA equivalents, which means if you look at the new proposal of 4.4 nanograms per liter, that 1 nanogram of them all is more than this 4.4. Just keep that in mind. Okay, I'll continue with my next slide. I hope this one is clear. Because there's the amendment, which was suggested to the Groundwater Daughter Directive of the Water Framework Directive for 24 PFAS. It was recently in consultation. It suggests a water quality standard for the sum in PFOA equivalents of 4.4 nanograms per liter, which level is to be achieved by 2033, which is very low. I'll show you in the environment data later on in this presentation. The critical exposure is drinking water, because that directly goes to the tolerable daily intake. Based upon EFSA, of course, on this 4.4 nanograms kilogram body weight per week. And this is a nice opportunity also to point you, keep the number 4 in mind. 4 is everything. 4.4 nanograms per liter for water quality, 4.4 nanograms per kilogram body weight per week for the EFSA value. And later on, there will be another 4. Already remark, the RPFs that are suggested in the amendment of the Groundwater Daughter Directive are a little bit different than RVM RPFs. The RVM always uses the maximum number in interval. The European Union has averaged them, because for not all of those PFAS compounds, data were available. So what RVM did, they made an interpolation between, let's say, C5 and C8, for instance, and they always took the maximum of the interval. The European Union averaged those. So there's a slight difference between the two. Now, look at the relative toxicity of PFAS. The RPFs that the RVM has proposed are adopted by the European Union and already by other countries, for instance, like Switzerland. And they are the basis for this annex. When you look at US EPA, and just recently, just a week ago or something, they introduced a hazard index for 6 PFAS in drinking water. A hazard index is something different than the maximum concentration level that they also proposed for PFAS and PFOA. And when you look at the RPF factors from RIVM, and you look at US EPA levels that they proposed, you will see that they're not completely in line. You see that the PFAS and PFOA and PFHXS are nearly the same, they're equal, but PFNA already is different. US EPA says it's less toxic, whereas we say in the Netherlands that PFNA is 10 times as toxic as PFOA. Gen X also differs. PFBS is rather similar. But what's the origin? Yes, there is. I mean, you look at the US EPA values, and that's remarkable. At the beginning slide, I showed you that the health advisory level for drinking water in the US is 4 picograms, and over here says 4 nanograms. US EPA suggested values that are realistically achievable. The picogram level is not realistically achievable. So there's an order of 3 orders of a magnitude difference between the level that they suggest as a maximum concentration level and the health advisory level. Keep that in mind. So they did a pragmatic feasibility assessment, I would say. What can we logically propose? So not the health levels, the health risk levels, but for instance, an analytical level. Now, and then how did REM go to that 7 picograms per liter? What we, I think, all know, there's an annual average environmental quality standard for PFAS in surface water in the European Union for 0.65 nanograms per liter. But keep in mind, that's based upon a very old tolerable daily intake, but it incorporates bioaccumulation in fish. If you look again at the new EFSA tolerable daily intake, and we take into account the RPF factors that we just looked at, but also an RBF, which is a bioaccumulation factor, so PFAS accumulate very strongly in fish, then you arrive at a different number. So what did we have? We had the 0.65, which if you take the new tolerable daily intake, the RPFs and the RBFs into account, you will go to the levels in the left-hand column. You will see for PFAS 7 picograms. For PFOA, it will be 0.3 nanograms, for Gen X 10 nanograms per liter. These are, of course, incredible numbers. And the most thing which struck my eye is that, for instance, there are components like, for instance, PFNDR, they are 0.4 picograms per liter in surface water, which is incredible, of course, because that's less than half a human hair and all the human hair in the world. So this is just to give you an example how little it is. But mind you, I was thinking, how many molecules are this? Is this one molecule? No, this is still, let's say, 1 billion molecules. So in molecules, it's a lot. In grams, it's unmeasurable. And then some reflection. We are in Europe. We mainly look at European endpoints. But there's also a World Health Organization. And this was a draft version that I saw in September last year. And the World Health Organization considered that uncertainties in identifying the key endpoints are too significant. So they say we cannot derive a human health-based guidance value with confidence. They looked at the EFSA opinion and they said the EFSA opinion is based upon one study which looks at the reduced number of antibody after vaccination in toddlers, so in babies. This is a very meager or uncertain endpoint. And what he also said, the clinical implications are uncertain because we don't see a relationship with increased rates of infection in those babies. So they don't see sickness as a result. So they say the EFSA endpoint is, in our point of view, too uncertain. So we stick to a guidance value of 100 nanograms per liter or 500 nanograms per liter for PFAS in total. That's what they say. So it's just, I don't give an opinion over here. I just say there are important parties in the world that look at it a little bit differently. And there's also the UK Committee on Toxicity that also produced an opinion, and they say that data and evidence on the EFSA advice are too uncertain and should be used with caution. At the same time, the UK Committee on Toxicity says, well, we don't have anything better, so we can use it, but it is very uncertain. So keep that in mind when you use all those values. And mind you, we are building a huge framework of risk-based levels, etc. European Union is using them for the groundwater daughter draft. It has huge implications. And a couple of organizations say, well, take care, it's uncertain. And again, I don't give an opinion about this. I just noticed this. It's just an observation. Okay, this was everything about guidance values, etc. I'm now moving to environment data. To put this in perspective, what are we doing? So, where are we going to look at? I'm going to tell something about soil and blood. It's mainly based upon data that I've seen in the Netherlands and a bit of in Flanders. So if you have any additions, they're welcome to mention. Now, background concentrations. A native speaker said to me, you should talk about ambient concentration because this is not a natural background. This is artificial. So talk about ambient concentrations in soil for PFAS and PFOA. He then again should realize that as a non-native speaker, I must think what means ambient. So I'm talking about background here. These graphs don't look at the pictures. Just keep in mind, in the Netherlands, the P95 for PFAS is 1.4 micrograms per kilo, and for PFOA it's 1.9 micrograms per kilo. And you see a big circle in the right-hand picture. That's in the center of this circle is the DuPont Chemours factory in Dordrecht. They had huge air emissions of PFOA. So the RIVM excluded these data in that circle from their interpretation. So in the rest of the Netherlands, you will see that the ambient concentrations are 1.4 and 1.9. A bit later, we saw the ambient concentration in Flanders, in Belgium, and they differ a little bit. PFAS is a bit higher, 1.5, and mind you, that's the P90. So if it would be the P95, PFAS would be a little bit higher, I guess. And PFOA is much lower. So there's a difference between the two countries, which is strange because I think Netherlands and Flanders, we speak the same language, but why is there a difference? And we act more or less similarly. Why is there a difference in ambient concentrations? For this, I go to the conceptual model of air deposition because we both have factories that produce PFAS. When you produce PFAS, there's emission to the air, and you see that there's vapors coming out of there, which they coagulate and they form small minor particles, and there's air deposition of PFOA, PFAS, etc. And it deposits everywhere in those countries. So looking at Dordrecht, for instance, where we as the expertise center on PFAS and as Arcadis have done a lot of work, you will see that in the center over here, that's the pointer. So over here, there's the factory of DuPont Chemours. On the right-hand side, you see a windrow. So that's the direction where the wind comes from. So when you look at this graph, you will see that the concentration in soil, these are all micrograms per kilo concentration in soil. You see that in the Rotterdam area, and over here you'll see this is Rotterdam, big city with a lot of, it used to be the biggest port in the world. You can see that concentrations of PFOA in the topsoil are somewhere around 1 or perhaps between 1 and 1.9. But in the plume of the DuPont Chemours factory, you see concentrations over 10 micrograms per kilo, and in some areas even higher, even over let's say 60 micrograms per kilo. So which is, of course, a deposition of Dordrecht, which must have led, if you look at the modeling and the study that we did in the neighborhood of this factory, have led to elevated concentrations further on. Because what do you see in those pictures? In the right-hand side, that's easy. These are concentrations of PFOA in the topsoil in relation to the distance to Kimur. And mind you, this is in all directions, also above wind. And there's one peak that disturbs it, but that has to do with the soil type. So this peak is mainly caused by the soil type in that area, which is peat. And we always explain things as micrograms per kilo soil. But in fact, you should look at, in this case, if it's aerial deposition, micrograms that are deposited per square meter. And that's what we did in the left-hand picture. So in the left-hand picture, you see in the colored areas an interpretation of the measured results in the soil. So for instance, when you look at the red areas, red is 10,000 to 20,000 micrograms were deposited per square meter, for instance. And the contours is a result of computer modeling of air deposition. So if we take into account what was in the permit of Dupont-Quémour and what we expect they have emitted over time, then you would get the contours, which are in line with what we measure in the soil, of course. And in this picture, when you look at the modeling of the emissions, we note that only 10% of the emissions deposit in the Netherlands. So if only 10% deposits in the Netherlands, the rest of it disappears in the Northern Hemisphere. And we know that background concentrations in the Netherlands outside that area of, let's say, 15 to 20 kilometers, where it's obviously elevated, we know that background concentrations might be elevated as a result of air emissions as well. And then moving to Belgium. Wait, oh, sorry. Still, the first is there's something else about blood. This is also the factory of Dupont-Quémour. And in 2016, 2017, our RVM did some biomonitoring, so concentrations in blood in people living around the factory. And you see that in the dark blue area, this area, you see that people have an average level in the blood of 10 nanograms per milliliter, which is 10 micrograms per liter of PFOA, only PFOA in the blood, which is above, let's say, the control and the European background. So that's the first indication of PFOA in blood. When you look at levels in blood of residents within 3 kilometers of the 3M site in Antwerp, so we were just in Dordrecht. Dordrecht's over here. We're now moving over here to Zwijndrecht near Antwerp. You can see there's a circle to the right-hand side. And what did they measure in blood in that area? You can see that there's a median of 20 micrograms per liter of PFAS, 25, when you take 20 is the total, sorry, in blood at those residents around that factory, which is high, just as an expression of blood around that factory as a result of aerial emissions. Now, saying something more about PFAS and blood serum. There are many studies, and I just have a few, which are, some of them are already a little bit older. And what they all say is that, well, if you look at the small numbers over here, and that was the question I had at the beginning of this presentation, it's around 20 micrograms per liter. And you see that the composition in Münster in Germany is changing over time. You can see that, first of all, it was the blue, there were the sulfonic acids, and then it changes. We see more precursors rising. And as I said, this level is not uncommon. The good thing is, for the FC4, it seems that levels are dropping. So when you look at the right-hand side picture, for PFHXS and for PFOS, you can see over time that levels are already dropping as a result of the restriction and the change in production of 3M and Dupont-Quémour. you can already see that levels in blood are dropping. So restricting PFAS is the best remedy against everything. That's my opinion. And also for PFOA, you can see that levels are dropping. So that's the good news. Keep that in mind. That's the good news. They're still too high, very much too high. But the good news is they're dropping when you restrict PFAS in products and the production of it. Now, there are a few more production sites in the Netherlands. This is a picture that we took from the article that was in the press, I think a month or so ago. So there was a journalist network that did a lot of research on PFAS production sites. And I just talked about the Netherlands and Belgium, but there are many more production sites around Europe. So I guess what we've seen in the Netherlands and in Belgium as plumes in soil and also in groundwater, I must say that there must be more areas around Europe where we have similar situations. I don't know if they had aerial emissions, so take care. But, well, there might be an impact over there. Now, moving on to some environment data in water and vegetables. I see I have to watch the time a little bit. This is the sum of PFAS in phreatic groundwater in the Netherlands. What you can see is that in phreatic groundwater in the Netherlands, there's around 13 nanograms per liter. I just talked about the proposal of the European Union, the Groundwater Daughter Directive 4.4. In the Netherlands, obviously, we are about 6 times or more above that value in our phreatic groundwater. Even in our middle deep groundwater, it's around 6 nanograms. There's more PFAS already. Obviously, there's a difference between industry, agriculture, and urban areas and nature reserves, of course. There's a difference because we as humans, because it's in our products, we produce PFASs. Now, moving on, keep that in mind. There's a lot. And then the Netherlands, we have a delta region. What about PFASs in the main rivers in the Netherlands? I only included the Rhine and the Meuse. I'm not going to talk about the Shell because there's a lot of it coming from Belgium, so I don't want to offend Belgium, but I can assure you that levels in the Shell are higher than these. What you can see in these graphs are over time 4 different monitoring points along the rivers in our country. And in the blue line, in the top graph, you can see where it enters our country. That's the entrance in the Netherlands. You can see that at least in this period, the concentrations over here at the entry point are lower than further downstream, which means that at least over this period in time, it seems that concentrations increase in the Netherlands. So we thank our neighbors that we get a lot of PFAS from them. So this is from Germany and Switzerland, and obviously there's some sources in Germany and Switzerland where it means that we get some PFASs. And the same is for the Meuse, where it comes from Belgium and France. We can see the entrance in the Netherlands is lower than what we find further downstream. And mind you, much of our drinking water is made of surface water from those rivers. And in our country, we think the sources are wastewater treatment plants, the paper industry, perhaps some landfills. And then some other water data. And this is from the article of Emconsoil, but that I referenced at the beginning. What we do see is that there's the sum of those 4 PFAS in rain is around, let's say, 1 to 2 nanograms per liter in Europe. So compare that with what we're writing in the Groundwater Daughter Directive. And this is only the sum of 4 PFASs. If you're unlucky and in rain is a lot of PFAS, then the sum of PFAS of, let's say, around 2 nanograms per liter will very quickly go towards the 4.4 nanograms per liter. And this is in our rain, what falls on us every day. And then this, I think in Belgium, they know these data. There's also PFAS in seawater and in foam. And I think many of us were shocked when they saw this. The sea foam in Knokke contains an average of 2,000 micrograms per liter. Would that be 2 milligrams per liter? Which is huge, really huge. So there's a lot of PFAS in there. So, and obviously this comes from the rivers to the sea, and then somehow it ends up at the beaches in this foam. And this is relatively recent data. I was also going to say something about vegetables. Arcadis did, together with the municipality in RWM, a big vegetable study on PFAS in vegetables around the Camur factory in Dordrecht. And what you can see in the graph on the right-hand side is, in fact, concentrations in vegetable gardens over this line. So you can see that in the garden BS, which is over here, concentrations in vegetables are very much higher. And then you can see in E and in BP, which is over here, and in D and F, downwind, within, let's say, this dotted area, concentrations in vegetables are higher. And there's an advice not to eat vegetables from the area BS and the area A, E, BP, D, to restrict it, to change your feeding pattern from the vegetable gardens with vegetables from the shops, from the supermarket. So change where you get your food from. Obviously, this all due to elevated concentrations in both soil, groundwater, and perhaps even from aerial deposition that's taking place right now, because we see a big contribution of Gen X over here, which is a bit strange when you look at concentrations in water and in soil. So why is there a lot of Gen X? Perhaps it has to do because Gen X accumulates much easier in vegetables. We don't know. There may be some more causes. Then I included this graph. When you look at water, the blue part is water, the orange part is food. What is the contribution of food and water to the total weekly intake in the Netherlands? This graph is being updated by RWM because these are based upon all data. But we're mainly talking about restrictions in water, but take care. Most of our PFAS, our intake of PFAS, is from food. So we also have to look at that chain as well, and which is part of the investigation that is being carried out in Europe and in the Netherlands by RWM as well. Look at what's in food, because I think that's the biggest contribution to what we get into our bodies. That's the cause of our high blood levels. Now something else. What's in our consumer goods and what's in dust? What do we know about these? We performed a study, a colleague of mine, Arcadis, we did for our ministry, performed a study of PFAS in dust, in waste streams, etc. And what you can see over here, and look at the scale of this graph. I mean, this is thousands of micrograms per kilo. So in this dust of this printing shop, there was 4,000 micrograms, 4 milligrams in a kilo of dust, which is a lot. And you can see in the colors that there's many different components of PFAS in there. So not only PFAS before, but short chains, precursors, etc. Things that are difficult to measure. And also in processed water, for instance, from the paper industry, from the recycling industry, there's something in recycling of tapestry, which is over here, carpet fluff. Carpet fluff is being used as a substrate in our vegetable growing industry, in the glass house industry. So which is really a bit worrying. We have to look at that as well. How does it end up in carpet fluff? Of course, because we use a lot of sprays. And moving on. Dark matter. We all know that there are thousands of PFAS compounds, and the most target analysis only are, let's say, about 28 or 32 defined components of PFAS present. And when you look at different ways of analyzing, in the center column, you can see what we were able to identify with target analysis. So we could say, okay, in dark green, we can see there's a long chain PFCA. But if you look at the total fluorine content, there's a big difference. There are many products, car textiles, leather sprays, water repellent sprays, outdoor sprays that contain a lot of fluoride. But when you look in the last column, how much the target analysis accounts for the total fluorine, we only see 2 products where we can at least, when we can say, well, let's say 20 to 40% can be explained by compounds that we really can identify, which means that if you have a product or whatever, and you do a target analysis on PFAS, you will not find the dark matter. You will not find those components that are not identifiable by ordinary analysis. This is still an area of research where you have to improve things. Now, slowly getting to an end. I already told you, prevention and restriction is key. But when you look at the blue area, and this is very a rough graph in an older article, but it just illustrates what happens. In Europe and Japan, we restrict things. But in the rest of the world, like India, China, Russia, PFAS are still at their top and hardly being restricted. So when you import things from China, take care. Now, just to recap, I showed you a lot of things. How much is there? And I tried to express it in the same, how do you say it, in nanograms, everything in nanograms. You see what's on average you can find everywhere. So 1500 nanograms per kilo in soils and water phreatic 30, etc. Dust households, 1 million, blood serum, 20,000 nanograms per liter. And where we're going to, I think, is this 4.4 nanograms per liter. Just reflect that against the 1500, the 10 nanograms per kilo, or in dust, or in blood serum, or consumer goods. There's a big gap. And these nanograms per liter are not in line yet with the 7 picograms of US EPA, or the 7 picograms of the surface water advisory level from RVM, or the 4 picograms of US EPA. US EPA suggested the 4 nanograms per liter. So what are we going to do with surface water over here? A realistic level is somewhere that we can measure and what we can manage in our cleaning industry is, let's say, 1 nanograms per liter, or just above 1 nanograms per liter. And this, in fact, is also the level that we are seeing for soil vegetable gardens. And this is the intervention level in soil. So, and this is why I think, and that's one of my concluding remarks, we need to be careful in the European Union to adapt the new amendment. The new amendment says we have to go to the 4.4 nanograms per liter. But if we have more in our groundwater, if we already see that it's 30 nanograms per liter, what are we going to do? Immediately go towards a derogation? It's very much defendable from a risk perspective that we should go to the 4.4. But I think it's too big a challenge. When look at ambient concentrations, it's too big a challenge for chemical, analytical capabilities, or our capabilities in water treatment. It's a huge challenge. Now, my last slide. Obviously, any level of PFAS has risk. That's for sure. Prevention and restriction and only dilution can mitigate our diffuse issues. And so the monitoring background levels is extremely important. I think the monitoring in Belgium of groundwater levels is still going on, but it will be in Q3, Q4 that it's being reported. Advisory levels are not remediation levels. Think about sustainability. So the thing is, if you have to go to very low levels, the impact for climate change or the impact of energy that you need or the waste that you're producing is extreme. Currently, we are executing as the Expertise Center on PFAS and Arcadis a study on where to go with our PFAS waste. I can assure you, all the treatment facilities that can burn PFAS are at their max already. So if we have more that we want to burn, there's no capacity in the European Union. And it's very difficult to realize new ovens. Now, think of relative toxicity in dark matter, awareness and responsibility. I want to point you at a quote of Ravi Naidu. We need to raise awareness of citizens and consumers worldwide, that they begin to demand products that are not toxic and do not leave poisonous pollution behind them. So PFAS are really great substances for our raincoats and for our baking pans. But please realize, be able to revert to a product that's perhaps less perfect, because this perfect product is spoiling our environment. Major thing is we have to tackle sources and improve our technologies. Okay, I think, let me check. Oh yes, there's a lot of PFAS information around. I'm not able to read everything. I think you will have difficulties in reading everything as well. So, and this was my last slide. And I will stop sharing my screen. I see Johan is already on the screen.
Okay, Hans, I'm really grateful for your fantastic presentation. I have to say I had some high expectations, but you have no problems to surpass them even. So this was really fine. So let's go immediately to the questions I already have in the chat. So we have already 2 questions. Let's start with it. This one from Griet van Gestel. Thank you, Hans, for the interesting presentation. Should we use the ALARA principle also for setting standards for soil and groundwater? What's your reaction?
That's a difficult question. Then I should say that's a good question, but a difficult question to answer. Because, in the Netherlands, as well as in Flanders, we have a, how do you call it, a perspective how to deal with reuse of soils, etc. And that contains many principles. It's built upon the standstill principle. So in dealing with soil, we're looking at the standstill principle and the duty of care, of course. Looking at remediation levels, I think going to as low as reasonably achievable is a principle. You could also look at a sustainable principle or a BETNAIC principle. And you could also look at it from a sustainability appraisal point of view. We did already a couple of appraisals for a couple of firefighting training areas, and that's really difficult. There's no straightforward answer, I would say, because if you want to redevelop a site, what are you going to do? Are you strictly going to look at risks? Because risks in our country for a garden where you don't grow vegetables or a garden where you grow vegetables is different. If you're going to look at risks and a resident is going to do some excavation activities, he has to transport its soil. What's he going to do? So it's difficult. For groundwater, also very difficult because many of our groundwater is already above that level. So are we going to treat that groundwater? I don't think so. I hope that's an answer.
Yep. Okay, thank you. I see a bit smaller remark from Katje Touchon. Well done, Hans. Your presentation nicely summarizes the knowledge and insights gained over the past 2 years. There's also a reaction from Grit with a thank you for the answer. I don't see immediately other questions, but I also have a question because when we look to all those concentrations, certainly in the dust in houses, and if we compare it with what we see in concentrations in soils, then we put a lot of money or also in investigation of soils, and also I think in next years there will be put a lot of money in remediation. Is there, and it's perhaps a stupid question, is there something like an idea that you should also remediate in the houses and that you would take away the dust? Or is there still a new exposure because the new PFAS are brought into the houses? Or is this also a historical legacy?
Well, again, that's a very good question, Johan, where it's difficult to give an answer immediately. I think I give a part of my answer was in the fact that I think a rapid restriction and a thorough restriction is key to reducing those, because it will not be feasible to remove all this PFAS and all those dusts. And dusts, at least when we do a good housekeeping and we remediate everything, we will be able to get that out of our system. And we also have to realize that it's already that levels of PFAS in the past were higher. PFOS and PFOA were much higher. And also PFOA and PFNA were higher. And those are the PFASs that are most toxic, that you can see in your RPF factors. So at a very high level, I would think if we restrict them as quickly as possible and we take care that the PFAS with also RPFs are restricted as fast as possible, that they will disappear in the end, but it will take tens of years. If we're going to put a lot of energy in remediation in houses and in print shops, etc., there may be some guidelines for all of activities that will be very good. But like I said, if we're going to say that everything is PFAS waste, we will have big issues as well, because we don't have the burning capacity. And there's a lot going on in the waste business right now, it's my perception, and I'm not sure which way that's going to go. I mean, you know the discussion around, for instance, Indevair in Antwerp. At what temperature is burning effective? And I'm sure that the industry does its best to burn it, but let's be honest. We also have to realize that we produce waste, that we bring it somewhere, so we have to work together with the waste producing industry. That's the thing that I think, and we should take care that waste doesn't end up in the gray circuit. That's one of the things that I'm most afraid of, to be honest. Yeah.
Okay, someone else who wants to raise a question? You don't have to do immediately in the chat. You can also unmute and ask your question to Hans.
I hope everything was clear, what I said about before equivalence, about the guidances, etc., about the graphs.
I do not immediately see other questions.
There's still 100 of people in the meeting, which is
there's
good.
A question from Peter Schroten. Yeah, Peter, you can unmute and ask your question.
Yeah. Hans, I mean, if you're looking at the general exposure in population, what would be the prime exposure routes you would attack to reduce exposure in general? So the ones you would think, okay, you would have the most exposure from, and say that would be our main target to focus on to reduce the total PFAS exposure.
Yeah, I showed you the graph of the tolerable daily intake. And to be honest, I'm not sure how well we understand what our intake is overall, because we've got an intake by food, by water, by air. And I showed you that food is the most influencing parameter. At least that's what we think based upon all the data. So we should carefully look at our food. And I think in Flanders there's a guidance on levels in agricultural soil. What's being looked at from risk perspective. That's the study that was produced, I think, last year. Johan, you might know better than I do.
Mm-hmm.
We have a similar guidance in the Netherlands, and well, those guidance values, at least in Belgium, what I know, is also partly based upon ambient concentrations. So there's still something in our vegetables which we don't know. So we should have a better view upon what's in our food. And the food contact materials, of course, so pizza boxes, etc. So that's the main intake for us.
Okay. There's also a question from Katje Touchon.
Well, it's more an answer to Peter, actually. We are finalizing at the moment our HBM study around Zwijndrecht. And there will be also a modeling expertise about the exposure routes that are the most important for that region, not only for Zwijndrecht, but also for some surrounding living areas like Calais, Burgt, Antwerpen, and I think I've got them all now. So it's in the end, and I think it will be communicated at the end of April and or the beginning of May. So it's
and
coming.
Can you give a glimpse, Katja, about the outcome? Is it a bit in line with what I said, or am I completely wrong?
Of course. Otherwise, I wouldn't have been saying "well done, Hans."
Okay, thank you.
No. It's actually indeed the background exposure by eating food, commercial food. It's a very an important one. But also when you, and you already said it, when you have chickens and you produce your own eggs, or if there is a vegetable garden, those roots are also playing a part. And then the PFAS compound also plays a role. It's not always eggs or the vegetables. It depends on the PFAS.
Yeah.
But
Well,
it's coming.
Okay. One interesting thing is that I'm not sure if, because the study in the Netherlands is not that extended as in Flanders, that you see PFAS in eggs and chicken, I believe, which in the Netherlands, PFOA in chicken and eggs is not that prominent.
No, PFOA is not prominent in eggs. So that's what I mean by you have to look at the PFAS, and PFOA is not really in high concentration in eggs. That's more the PFOS, for example. But it will be all in the study at the end of April and the beginning of May.
Okay. I'm looking also to in the chats. There's just a question about in what way the PPT would be available. We prefer to have the presentation. This presentation is recorded, and you will have the possibility to look back at this presentation. So that's all to answer that question. And then there's yeah. Of course, it's clearly also the question what I see from Andy Hurkmans has to do with priorities. That was already raised. What's the most important problem, and how can you spend our financial resources effectively to cope with the problem, apart from stopping using them? It's a little bit the same question that's coming back. Where lies the priority?
Yeah. Yeah, and it's difficult to answer, of course. I mean, more or less answered it financially. If you look in a prevention pathway, you have to look at food, and when you look at curing what's already been done, that's extremely different. I would say look at your main sites. So look at your firefighting training areas. I mean, we're mainly soil and groundwater professionals. And then there's, of course, what's very important in the Netherlands is look at your drinking water companies, look at your surface water. That's where we have to spend. We have to have good water quality.
Okay, and then a final question from Lars van Passel. Does the exposure modeling investigation also include exposure by contact with consumer goods?
I think it's mentioned to me, so no, not especially. It's more focusing on the environmental compartment and the impact on exposure.
Okay, thank you. So I want to conclude this fourth session of our webinars in this springtime in 2023. Of course, a big thanks to all persons who were attended this session. And of course, a big thanks also to Hans Slenders. I know you cannot give an applause in a digital way, but I would say send just a thumbs up for what has been presented here this 1 hour. This was really good. We have think also from Flanders what's in the Netherlands. Also, we have learned a lot. So thank you, Hans. And this was nice. I think in 1 year, if we have a new situation, perhaps we will invite you back again.
We will see you. Thank you for your nice words, and I hope I had an interesting story for you. So see you.
Okay, thank you.
Bye-bye.
Bye.